This new AI model has appeared unexpectedly and is already breaking conventional boundaries. It's not only twice as fast, but it's also more intelligent than many of its counterparts, and it wasn't even trained the usual way. That's right, no long GPU training sessions, no new data, just a groundbreaking method known as Assembly of Experts, AoE, that combines the best aspects of various models into one powerful system. The outcome is DeepS R1T2 Chimera, fast, compact, highly efficient, and potentially the future of AI. Let me explain how they achieved this. This language model integrates three previous top models, R10528, the original R1, and V30324, combining them into one entity that thinks faster, writes more concisely, and retains the intelligence that made R1 famous. The core technique behind this transformation is called Assembly of Experts, AoE. Let's break that down. Traditionally, to improve a large language model, you'd gather new data, launch a training run that exhausts cloud GPU resources for weeks, and hope that the new model doesn't overfit or hallucinate. AoE bypasses all of this. Each parent model holds thousands of corresponding weight tensors. Think of these as microscopic dials that control how the model responds. Instead of retraining, the engineers access the stored tensor files in PyTorch, select the most important tensors, and simply average or interpolate the values they want to adjust for each model. Technically speaking, they use Lambda 1 for V30324, Lambda 2 for R1, and Lambda 3 for R10528 before merging the results. It's just raw number crunching. The task scales linearly. Double the parameters, double the math, but it's still affordable. No gradients, no backpropagation, just straight tensor algebra, which any decent workstation can handle while you grab a coffee. Imagine it as a gigantic brain with 671 billion settings, but instead of using all of them simultaneously, it only activates about 37 billion per word. A built-in router determines which 8 out of 256 mini-experts should handle each word, depending on the specific need. This setup makes the model incredibly efficient, roughly 18 times cheaper to run than one that uses all of its settings continuously. And since all the DeepSeek models use this same setup, the AoE method allows them to mix and match components, like puzzle pieces that always fit together. Now, why does R1T2 feel different? Let's talk about speed. Benchmark tests show that Chimera produces results about twice as fast as R10528 and over 20% faster than the baseline R1. These speed improvements come from two places. First, the routed experts from R1 maintain deep reasoning capabilities, and second, the shared and attention layers mostly come from V30324, which was optimized to produce concise answers. Combine these, and you get a model that reasons like R1 but talks like V30324. So, each response uses fewer tokens. Shorter output means less GPU time per answer, and lower costs for anyone using the model at scale. But speed isn't the whole story. People often worry that shortcut merges might compromise quality. So the TNG team rigorously tested R1T2 across multiple standard exams. On MT Bench, it scored almost identically to R10528. In GPQA Diamond, which tests deep factual recall, it performed between the two parent models. On AIM 2024 and 2025, which challenge math-solving abilities, it matched R1, sometimes outperforming it, while still trimming down text. In the Big Code benchmark, the model excelled at generating clean code blocks and following structured instructions, thanks to V30324's influence. The important takeaway is that AoE preserves expert-level reasoning, ensuring the chain of thought remains clear and readable. You still see every calculation, but without unnecessary commentary. Now, things got really interesting. As the engineers gradually increased R1's influence in the mix, especially beyond the 50% mark, The model began outputting answers enclosed in tags, much like R1's responses after its reinforcement learning phase. Below that threshold, these tags didn't appear at all. A slight increase, and suddenly they were present in nearly every answer. The same thing occurred with token count. Even a tiny increase in R1's contribution made the answers noticeably longer, and reducing it shrank the responses. This sharp change indicates that certain behaviors are locked in very specific corners of the massive 671 billion parameter space, and AoE allows the team to access those corners without disrupting anything. This discovery led to a new approach. Instead of merging all aspects of the models, they focused solely on R1's expert layers while keeping the attention blocks, shared layers, and routing systems from V30324 unchanged. In this configuration, the model retained R1's deep reasoning while maintaining the speed and efficiency of V30324. The lesson was clear. R1's advanced thinking resides in its expert layers, and V30324's structure is more than capable of managing them. With this knowledge, TNG fully committed to using R1's expert tensors at their full capacity while leaving the rest of the model entirely based on V30324. The result, DeepSeek R1T Chimera. Released under the MIT license and uploaded to Hugging Face, by late May, the model was already processing 5 billion tokens daily through their Shoots serverless platform. This wasn't just a research project. It was a practical, scalable solution. Community feedback came in fast. On Reddit's local llama forum, early adopters praised R1T2 as the first Chimera model that truly felt like an upgrade rather than just a gimmick. Users highlighted its quick responses, grounded tone, and fewer hallucinations compared to both R1 and V30324. Math-heavy workflows in particular saw the benefits. The model kept its chain of thought clean while skipping redundant steps, trimming compute costs without sacrificing clarity. In terms of hardware, the team tested R1T2 on 2 different clusters, 8 NVIDIA H194GB NVL cards on one side and 8 AMD MI325X 256GB boards on the other. On both setups, R1T2 outperformed its parent models in terms of latency, proving that the Fusion doesn't rely on any special CUDA tricks. For businesses paying per millisecond of inference, this latency drop translates to direct savings. The environmental impact is another hidden benefit. Sparse activation already reduces power consumption, but by discarding 40% of the tokens, the model reduces memory transfers by the same amount. Given that R1T2 handles 5 billion tokens daily, this results in significant carbon savings over time, even if the numbers aren't immediately headline-grabbing. Let's dive deeper into AoE. The method compares pairs of layers or tensors from the parent models using something called normalized Frobenius distance. This just means measuring how differently 2 layers are scaled to their size. If the difference is small, below a threshold they call delta, that layer can be skipped because it's essentially the same in both models. Setting delta to 1.5 means merging almost all the expert layers and any standout attention layers. Increase it to 2.5, and most of the shared layers stick with the V30324 base, leading to even cleaner, tighter responses. But if you push past 3, the model starts to lose intelligence because too much of R1's expertise has been removed. The key takeaway isn't about memorizing these numbers, it's about understanding that you can fine-tune which layers to keep or skip to create the best blend, rather than indiscriminately averaging 2 entire networks. Next is the idea of the parameter valley. When the team plotted the results from different blends, the graph didn't resemble steep mountains or cliffs. Instead, it looked like a smooth hill, meaning that most combinations of the parent models resulted in a usable model. So rather than trying to avoid disastrous merges, you're exploring a wide open space of solid hybrid models. AoE is the tool that helps you navigate this space. And it doesn't stop with DeepSeek. any group of models following the same structure, whether Gemini, Qwen, or future OpenAI MOI models, could be sliced, blended, and reassembled the same way. You no longer need to wait for the perfect fine-tune. Grab models with different strengths, one for vision, another for math, maybe a third for code, and merge them to create the ideal configuration. All you need is enough storage space for the tensor files and the time for PyTorch to do its thing. For developers building real products, this isn't just an experiment, it's a money saver. If your chatbot needs to show its reasoning for legal, medical, or financial applications, R1T2 delivers clear logic without excessive token usage, reducing costs every time a question is asked. And if your product needs to respond in real time, such as an assistant running in a browser, R1T2's speed boost, twice as fast as R10528, could be the difference between lag and smooth interactions. Plus, with the MIT license, there's no legal red tape. You can plug R1T2 directly into your backend and go live. Training costs are another big consideration. Pre-training a model like this at 8-bit precision requires tens of trillions of floating-point operations per weight. Throwing that away to retrain a new model from scratch is wasteful. AoE allows you to reuse previous investments, add new features, and keep improving without ever touching gradient descent. It's faster, cheaper, and more environmentally friendly. Lastly, there's a neat twist. During benchmarks, the team forced each model to start its response with a less than think greater than tag to see if the reasoning trace would appear. V30324 barely followed through, but R1 always provided the correct closing tag. Interestingly, in the merged model, as R1's contribution hit exactly 0.544, the model started consistently producing those tags. This is an emergent trait, behavior that only activates once a specific balance is achieved in the model's structure. If you're a researcher seeking to understand how these models think, this is invaluable information. That's it, you're now up to speed. If you have any questions, ideas, or wild merge combos you'd like to try, leave them in the comments.